Hi, in this video we're going to look at the most common way the Pythagoras equation enters into some AMC geometry questions. So let's jump into our example. A square ABCD has side length 2, a semicircle with diameter AB is constructed inside the square, and the tangent to the semicircle from C intersects side AD at E. What is the length of segment CE? Now, it's not obvious how to proceed here, so let's draw in some lines to help us and try to work around the figure. So we have a square of side length 2, so let's write in CB of length 2. DC is also length 2. One line that's pretty natural to draw is the radius to any tangent point, so let's draw that in. And let's just say that the point of tangency is point F. Now at this point we know that CB is equal to CF because we know from geometry that anytime you have two tangent lines to the same circle, those two tangent lines have to be of equal length. And you can see that pretty easily because you can construct two congruent right triangles to show that. So we know that CF is also equal to length 2. We don't know what length EF is, so let's just call that X for now. But by the same logic as over here, we know that AE is also equal to EF, so let's call that X as well. We can do a simple subtraction to find that the length DE is just 2 minus X. And at that point, we sort of realize that we have three sides around this right triangle, all written in terms of X. And that's kind of the critical point to apply the Pythagoras equation. So let's go ahead and do that. So we have the hypotenuse, X plus 2 squared is equal to this leg squared plus this leg squared, and we can expand that. Plus 4 is equal to 4 minus 4x plus x squared plus 4. Okay, so the x squareds drop out. That's good news. The 4's can drop out. We can bring the minus 4x to the other side. Oh, great. And we quickly find that x is equal to 1/2, and the segment we're trying to find, CE, is equal to x plus 2. So we know then that CE is equal to 2 plus 1/2, which is equal to 5/2, and that's choice D. So the basic pattern that you want to recognize here is that we work around this figure, introducing variables as needed, and once we cover all three sides of a right triangle, then that's the point that you want to try to apply the Pythagoras equation to help solve for these variables. Now, in some cases, you may end up with a quadratic equation or perhaps two variables, but in any case, you'll always be one step closer to a solution. So please check out the description section of this video for links to other Pythagoras-related AMC problems, and we'll see you at the next video. Take care.